Good morning, students. We'll now learn how to calculate index numbers. Now, in this question, we are given the prices and quantities of two years 2005 and 2009 for four commodities. So, given these prices and quantities, we are asked to calculate seven different index numbers. So, before we start the calculation, we have to label these prices and quantities. So, in the base year, the year which comes before, we'll label them P0 and Q0. In the subsequent year 2009, we will label them P1 and Q1. Now once we have labeled these, we can proceed to the calculation part. Now in the calculation part, let's go one by one. Before we calculate the prices and the index numbers, we have to multiply the prices and quantities of the two different years with each other. So we have to multiply P0 into Q0, P0 into Q1. So prices of 2005 with the quantities of 2005 and prices of 2005 with quantities of 2009. Similarly, prices of 2009 with the quantities of both the years. So when we do this multiplication, we get the following values given in the table, which you can verify by calculating by yourself by pausing the video and going back and calculating. So when we do these multiplications and once we calculate P0, Q0, P0, Q1 and so on, the final value which we need to obtain is the summation value. So sum of the P0, Q0 values is 1660. Summation of P0 Q1, so all the prices of 2005 into quantities of 2009 gives me 1470. So my total expenditure in that way would be 1470. If given the prices of 2009 and the quantities of 2005, my total expenditure would have been P1 Q0 gives me 2070. And sum of P1 Q1, so prices of 2009 with quantities of 2009, the total expenditure for me would have been 1790. Now given these values, we will use the formulas given on the right to calculate the three major index numbers: Laspeyres, Pashas and Marshall-Edgeworth. So Laspeyres is summation of P1 Q0 divided by summation of P0 Q0 into 100. Pashas is summation of P1 Q1 divided by P0 Q1 into 100. Marshall-Edgeworth combines both of them. So I take the prices of first 2009 in the numerator, multiply with quantities of both years. So P1 Q0 plus P1 Q1. Similarly, in the denominator, I have prices of 2005 multiplied by quantities of both the years. So P0 Q0 plus P0 Q1. And then I will calculate this value in the brackets and multiply it by 100. Okay. Then once we have done this, we will proceed to Fisher's index and we will also calculate Dorbish and Bowley's method. All right. So let's take a look at Laspeyres index method. So we take prices of both years, but we take quantities of only the base year here. So P1 Q0 divided by P0 Q0. So 2070 divided by 1660 multiplied by 100. That means 1.247 multiplied by 100 gives me 124.7. So this tells me 24.7% inflation. Okay. So this is all in percentage terms. All indexes are in percentage terms. Now Pashas index method gives me the results when I take the prices of the 2 years. Prices of 2009 in the numerator, prices of 2005 in the denominator, but quantities of 2009. When I take these values, so P1 Q1 summation comes to 1790, P0 Q1 summation comes to 1470. I divide 1790 by 1470, I get 1.218 into 100. That means 121.8 is my index number. That means inflation of 21.8%. Now Pashas index is the lower limit and the Laspeyres method is the upper limit of all index numbers. All the rest of the index number values will lie within these limits. Okay, so upper limit of 124.7 and lower limit of 121.8. Now let's next calculate Marshall-Edgeworth's index method. Here I have opened up the bracket. So in the numerator I have P1Q0 plus P1Q1. In the denominator I have P0Q0 plus P0Q1. So we'll take the values from the table and put them into the formula here. I get 2070 plus 1790 in the numerator, 1660 plus 1470 in the denominator into 100. So this gives me 3860 divided by 3130 into 100, which is 1.2332 into 100, which gives me 123.32 as my index number, which means there is a 23% approximate inflation. Now, when I calculate the Fisher's ideal index number, please note the formula is a bit different. So where in Marshall-Edgeworth's method, I added the last year's values to the Paasche values. Here we multiply the two indexes. So I take the formula for Paasche, take the formula for last year's index number. I multiply both of them with each other, and then I take the square root. So when I do this, I will get 2070 divided by 1660 multiplied by 1790 divided by 1470. This gives me square root of 1.247 into 1.218 into 100. So multiplying these two numbers and taking the square root, I get 1.2324. Now this gives me the index value of 123.24. That means there is a 23.24% inflation using the Fisher's ideal index. Dorbish and Bowley, what they do is they take Laspier's and Pasche's index, add them up, and take the average value of those two indexes. So where Fisher's takes the square root, Dorbish and Bowley suggest taking the average. So here again we add 1.247 plus 1.218, and as a result we get 2.465, and we take the average of this. So I divide it by 2 to get 1.2325 into 100, which opens up to 123.25. So by Dorbish and Bowley's method, the inflation is 23.25%. Now the next two indexes, Kelly's method and Wald's method, are a bit different. So I need further calculations for that. For Wald's method, I need to first multiply the quantities of the 2 years. So 2005 quantity with 2009 quantity, which I have already done here. Then I need to take the square root of that. So for each multiple, I have taken the square root in the second column. In the third column, I multiply P0 or prices of 2005 with this square geometric mean of the two quantities. So essentially we are calculating geometric mean of 2005 and 2009 quantities here. So once we have calculated that, we will multiply it with the price. So price of 2005 for good A with the geometric mean of 6.93 gives me 138.6. Prices of 2005 with the geometric mean of the quantities for good B over the 2 years gives me 7.07 into, let's see what is the prices here, 7.07 into the prices of B was 50. So so where the other methods were including both prices, here we are taking only one price, but we are taking both the quantities here. So quantities are more important in Wald's method. So similarly, we have calculated multiples of all the prices with the geometric mean of the two quantities and multiplied. Once we finished these calculations, we calculated the sum of P0 square root of Q0 Q1. I get the value of 1539.3. 1539.3. Similarly, again take the geometric mean of the 2 years quantities of each good and multiply with the prices of 2009. So when we do that, we get the fourth column values of 277.2, 424.2, 750 and 447.2. We add them up to get the summation value of 1898.6. Alright. So then we apply these values to the Wald's method formula. So let me just switch to the highlighter. Ward's method formula is summation of P1 geometric mean of Q0 Q1 P0 into geometric mean of Q0 Q1 in the denominator. So I take the values here 1898.6 divided by 1539.3, which gives me 1.2334. So I multiply this by 100 to get the index value of 123.34, which is 23.34% inflation. Alright. Now Kelly's method is a slight difference. Instead of taking geometric mean, we are taking arithmetic mean. So very similar concept, but just the type of mean is different. So here arithmetic mean of the two quantities Q0, Q1 and Q0 and Q1. Sorry, the labeling is a bit wrong. It should be Q0 and Q1. So once we take the 2 years quantities and we calculate the average of them, arithmetic mean, we get 7, 7.5, 15 and 22.5. Then we multiply with the prices of 2005 and 2009 to get the last two columns. So when we multiply with 2005 prices, we get 140, 375, 600 and 450. When we multiply by 2009 prices, we get 280, 450, 750 and 450. So the summation values of these two columns, when we multiply with the 2005 prices, the average of the two quantities, I get 1565. With the 2009 prices, when I calculate the arithmetic mean of the two quantities of the 2 years, I get 1930. So we are basically measuring how much of the index has changed based on the quantity change and not on the price change, price relative change. So here, as a result, when I substitute the values, I get 1930 divided by 1565 into 100. This gives me 1.2332 into 100, which is 123.32, which tells me there is an inflation of 23.32%. So like this, you will use these methods to calculate the index numbers for the further problems which are given as assignment.